Can you see my screen? Cool. So, hello everyone. I am Shresth, and I am a backend dev and algorithm designer at Paraswap, which is our decentralized exchange aggregator. And today we're going to have a walkthrough of different generation of DEXs and AMMs, how they've evolved, and what can be built next. So let's get started. Before we start, I would like to give special thanks to Munir, founder of Paraswap, Michael from Curve, Fernando from Balancer. As while I was preparing for my presentation, I thought the best way to get insights about DEXs and AMMs is to ask the founders themselves who have built them. So yeah, I've got a lot of very useful insights, and thanks a lot for that. So a quick into what are DEXs and AMMs. So a one-liner of DEXs would be, DEXs are decentralized exchanges where you can swap tokens directly from your wallet to your wallet without transferring your tokens to a third party. So you always have the authority of your tokens. And AMMs are types of DEXs where the pricing logic itself is programmed into the smart contract. So it's automatic. Now let's jump into the generation one of the DEXs. I call it the beginning. And the first is Ether Delta. I think this is the first major DEX. It was an order book based DEX, and I think that was the major issue. Maintaining an order book on chain is very expensive, as well as the UX. I mean, it was the first DEX, so the UX was not very good. It also had some hacks. And after that was the 2017 ICO era. And during that time, a lot of projects were funded, and I think 3 of them were DEXs, and I would like to point out 0x, Bancor, and Kyber. 0x and Kyber, they were also similar to Ether Delta, as they also had order book based DEX, while Bancor was I think the first AMM, as far as I know. And the way Bancor worked was using constant product formula. And let's look into how the pricing works for Bancor. So let's suppose you have a pool of token A and token B. The main idea is to maintain this variant that the product should be constant. So the reserve of token B times token A should be constant. Let's look into an example. So let's suppose you have a pool of avocados and apples. And initially you have 6 apples and 8 avocados. So your constant product invariant would say you should always have 48 fruits. Now let's suppose you want to swap using this pool, and you put 2 apples to get avocados. And as soon as you put 2 apples, the total number of apples in the pool is 8 apples. So you would get out 6 avocados. You would get out 2 avocados to maintain the variant that later on in the pool you would have 8 apple times 6 avocado equals to 48 fruits. But let's suppose that you swap 4 more apples. So then you would have 12 apples in the pool, and you would get only 2 more avocados out. So you see that for swapping, for getting first 2 avocados, you only require 2 apples, but for the next 2 avocados, you required 4 apples. So if you look the price per unit curve of the constant product invariant, it looks something like this. And just this simple pricing equation was programmed into the Bancor AMM. I think the second major important factor about AMM itself is the incentive to provide liquidity. With the order book based DEX, you have to continuously put orders, but with an AMM, you can just passively provide liquidity and you receive fees over that liquidity. So I think AMMs definitely have an edge over the order book exchange, and Bancor was the first in there, but still it did not get as much adoption as it could. I think the major issue behind that was it was because all the pools were paired with the Bancor token, which was, I think, slightly greedy approach. So every time you had to swap from token A to token B, you had to go from token A to Bancor and then Bancor to token B. Also, the gas was not very optimized. So yeah, so in summary, the generation 1 DEXs were, I mean, the order book was expensive. Order book based DEXs were expensive to use. They didn't have good enough UX. There was not enough incentive to put liquidity, and BNT pairing, even though Bancor was a good AMM, the BNT pairing was a very greedy approach. Then comes the generation 2 DEXs. I think this was the inflection point. And I would like to point out the first one as Uniswap V1. I'm not sure if this is the logo for Uniswap V1 because I did not find what's like, I found like 2 different logos and I was like, okay, maybe this is the one. And the main idea, so Uniswap V1 was similar to Bancor, but the major difference here was it was much more optimized in terms of gas. And second, it used ETH as a pairing. And I think that was it was better than pairing using Bancor. And then the second major DEX in generation 2 was Curve. And the main issue that Curve saw was when you want to swap 2 stable asset, and if you use the constant product formula, you can incur high price impact if you swap big volume. But using Curve, you can do that with very low price impact. And the way Curve works, and let's understand how the way Curve works. So before we do that, we need to understand another invariant, which is the constant sum invariant. And I think this is the most natural pricing curve. So it's basically you fix a particular ratio between the 2 tokens and it would look like, you know, a straight line. So if you move along the curve, like the slope is same, so the pricing is same. The main issue behind the constant sum invariant is if the price inside the pool is different from the price outside the pool, you can end up with just one of the token, like just one of the token in the pool, and there will be no incentive to rebalance. With the constant product invariant that we initially discussed, if the price is different in the pool and the price outside, then there is an arbitrage situation, and the arbitrage basically makes sure that the pool price is automatically rebalanced. So with Curve, what was proposed was something in middle. So the dotted line is the curve for the curve, and it is basically a curve which is in between of the constant invariant, like constant sum invariant and constant product invariant, and seems out that worked pretty well. And if you look at the price per unit curve for that, you will see that it will be the price will not move drastically when you are near to the pricing curve, and only when you buy very huge amounts, that's when your price follows the constant product. So after the generation, like after the curve, I think the most important is balancer. And to understand, before we get into how balancer works, it's important to understand impermanent loss. And let's look into the previous example that I gave with apples and avocados. So in the previous example where you had, like, let's suppose you were the initial liquidity depositor in this pool and you deposited 6 apples and 8 avocados. And let's suppose initially the price of all the apples were $1 each. So the idea with the constant product invariant is you deposit the equal value into the pool. So the price of per avocado would be calculated 6 by 8 so that it will be equal to $6 each. So you have $6 worth of apples and $6 worth of avocados, which is basically $12 worth of liquidity that you initially provided. Then let's suppose that avocados got more expensive. People want to get more fit, so avocados are less in the market. So now you have 12 apples in the pool and 4 avocados. You can see the invariant is still maintained. So 12 times 4 is 48. And the apple prices are still the same. So you have 12 times 1 is $12. But if you calculate the price of avocado, it will be 12 divided by 4. As we know that the value of both should be same, you just have 4 avocados, and so it will be 12 by 4. But if you look into the initial portfolio that you had before you deposited, you can see the worth of that portfolio in the current situation is higher. So it would be basically 6 apples, which is $6, and then 12 by 4 times 8, which will give you a total of $30. So you have $6 higher than your initial, than what if you would have deposited. So there is a risk involved when you deposit to an AMM, and with the Uniswap and the Bancor model, you had equal risk on both the tokens or both the assets that you deposit. But with Balancer, you can have a much diverse portfolio with different ratios. So you can say, okay, I want to have 30% exposure in ETH, 20% exposure in DAI, and rest in WBTC. And you can create pools with maximum, I think, 5 tokens. And you can have a portfolio which is self-balancing. So that is the main thing that Balancer brought into the DEX. Then came Uniswap V2. And the main difference between Uniswap V1 and V2 was it removed the pairing with ETH. So now you could have both tokens to be arbitrary. And second, the UX was also improved. So we had much simpler, the UI was better, and you could basically just take arbitrary tokens and then just give approval and simply swap. So I think, and then the next important DEX was Sushi Swap. I think the launch of Sushi Swap is very interesting because it used something called as vampire attack. The way vampire attack worked was it basically incentivized the Uniswap LP providers, liquidity providers, to deposit their liquidity into Sushi Swap. And the way they did it was, so people who deposit liquidity in Uniswap, they receive LP tokens, the liquidity token, the pool liquidity token. They can take these tokens and deposit into Sushi master contract, and then they can receive high Sushi rewards for that. And internally, the Sushi master contract has rights to basically migrate the liquidity from Uniswap to Sushi Swap. And this basically made Sushi Swap to grow liquidity pretty quickly. And after basically we had the launch of Sushi token, I think Uniswap also saw benefits in having its own token, providing incentive to provide liquidity. And that's when there was the Uniswap airdrop, and also there was Uniswap liquidity mining. And I think during that time was the main inflection point for Dexes. I took just a chart from DBank for the total traded volume, and you can see in the late 2020, we see the volume started growing drastically. And this was just the time when Uni did the airdrop and there was this Sushi Swap launch. And I think at this point, also in the generation 2 DEXs, I think it's important to mention DEX aggregators. And I would like to, of course, advertise Paraswap here. So, when you have liquidity distributed in so many different DEXs, it would get very hard to actually swap when you swap from one token to another, because you would have to go to different DEXs and compare prices to swap. And that's when you can actually use a DEX aggregator. You can simply just put the from and to token, and the DEX aggregator, so Paraswap here, would basically find you the optimal route, even using multiple token and multiple exchanges at the same time. So yeah, at this point, DEX aggregators were also in the boom. And in summary, the generation 2 DEXs had much better UX. they had incentive to provide passive liquidity, and we had high performing pools for stable asset. But we still had issues with generation 2. I think the two major issues were low utilization of liquidity for non-stable asset pools, and because there were so many DeFi protocols, there was basically gas was on fire because there was a lot of congestion in the Ethereum mainnet. And let's start by solving problem 2. So I think the problem 2 itself with gas, I think that it needs to be solved from the layer 1 basically, and a quick solution that we saw was the rise of side chains, and that was basically BSC, Polygon, and Phantom. I would say these were basically partial layer 2/side chains, as layer 2s itself, the real layer 2s were delayed, and these were EVM compatible, so people could quickly just take contracts from mainnet and deploy here. And as the transaction congestion was way lower on these side chains, the gas was also way lower. I mean, it's still very less. Like, you can do a swap in Polygon in less than cents, while you need, I don't know what's the gas price now, but during that time you would need at least $40 to do a swap in Uniswap. And I just made a fun picture of all the Uniswap forks. So all these side chains actually just had forks of the projects that were there on the mainnet, and the most of the forks were Uniswap forks. And as I'm working in a DEX aggregator, I have to deal with adding all of these Dexes, and I think there was so many different Dexes with so many funny names. It was quite interesting to make this particular slide, I would say. And of course, using Dexes on side chains using a DEX aggregator is much better, because you can swap using multiple Dexes while only needing very less gas. So you can see DEX aggregators would be much more handy with lower gas. And now we come to generation 3 Dexes, and what's the time? I hope I'm not getting over time. Okay, I have time. Yeah, so generation 3 Dexes were majorly focused on optimizing the liquidity. So we saw, like, with Curve, you could swap two stable assets with low price impact. But with Uniswap, with the constant product invariant, if you want to swap high volume, you would need to have very high liquidity. Otherwise, you will have very high price impact. And this was the major pain point that was solved with the generation 3 Dexes. And the first one I would like to mention is Dodo. Dodo uses a similar pricing curve like the stable swap invariant, but it works for non-pegged assets. And the way it does it is using an external pricing oracle. And the idea is you can move the stable swap invariant near the pegged price based on the external pricing. And there's the catch here that because it uses an external pricing oracle, the pricing oracle can be front run. So you could look at the transaction that's going to move the price and do an arbitrage using that. So the second major DEX in the generation 3 is Uniswap V3. The main idea that Uniswap V3 brings, I mean, it's very latest now, is basically the concentrated liquidity. And with Uniswap V2, where you provided liquidity for the whole price range, here you only provide liquidity for a small range of price. So whenever the current price is between your range where you provided the liquidity, your liquidity will be used in a concentrated way. But as soon as it moves outside the range, all the liquidity that you provided will be swapped into the other token. And this definitely was a breakthrough, because it is a breakthrough because it definitely utilizes the liquidity in a much better way, and people can have higher fees, but it comes with a few catches, I would say. First one is liquidity providing is no more passive. So you would have to actively maintain your liquidity position, which is much tough. Like for a normal user who is not a market maker, it is not very easy to move the price, like the price basically. And also the pool tokens are no more ERC20. So providing incentive for liquidity mining is much harder because it is in form of an NFT. So you cannot quantify whose liquidity is higher or lower. Then the major generation 3 DEX is Balancer V2. And the main idea that Balancer V2 brings is to abstract out the pool pricing logic from the main Balancer vault. So now you can deposit all your token in a single vault, and you can have different pricing logic. So currently, like the Balancer V2 was using the constant product invariant. And as we know that constant product invariant is not optimized for stable assets. So we can have a different pool implementation where you have stable swap invariant using the same balancer vault. So that's pretty good. Also, it is much more optimized in terms of gas. So you can use multiple pools and you would use way less gas as you would do in Balancer V2. And then I think is the most important is Curve V2. I think this is the killer. Because I think it solves most of the problems. It still uses the stable swap invariant, but it works for the non-pegged assets. And the way it does it is it doesn't use an external pricing oracle. It moves the peg on chain. So it calculates the profit and it moves the peg of the stable swap invariant on chain. I think the best way to understand more is look into the Curve V2 white paper. It's very interesting. Yeah. So after looking into the generation 3 DEXs, you might be thinking what lies ahead, what can be built in DEXs. And these are some of the points that I got while I was talking to different founders, as well as some of the points that I had personally while working in the DEXs and AMM space. And the first one is improved pools for non-stable assets. So even though Curve went quite ahead on having highly optimized pools for non-stable assets, I think there is still a way to go. Second is getting rid of impermanent losses completely. Yeah, it would be super good if we don't have impermanent losses at all for non-stable assets. Third is composable cross-chain pools, as we see that we are having a lot of different chains coming along, and in future I think there will be multiple chains. It would be good to have exchanges that work cross-chain. I think there are already quite some efforts done by Uni Swap and Thorchain, which are trying to do stuff like that. And then I think this is slightly non-technical, but very important, is clarity in legal regulation regarding DEXs and AMMs. I think this is one of the biggest problems that most of the founders, they mentioned to me. And then I would like to personally see collaboration across DEXs to solve bigger issues. So I think we are still way smaller than like in trading volume as compared to the centralized exchanges. And there is, I think, a lot of scope for improvement. And I think those can only be done when we have collaboration across DEXs rather than competition between the DEXs. So yeah, that's it. And I would like to say that I missed out some of the interesting DEXs, but just because to keep it short. And yeah, thanks a lot. And I'm open for questions. Sure. So first of all, like I don't know a lot of details about the math, but I can give you a general idea of how it works. So you have the stable swap invariant, and which is similar to what you had with the curve V1, but the stable swap invariant needs a peg price where it has a similar price to the constant price invariant, and this peg price, um, the main idea is somehow you need to calculate this, like the movement of this peg price on chain, and you need to do that in such a way that the liquidity providers itself, they don't incur any loss. And that's basically what the curve V2 brings us. They have a way to calculate the profit of the liquidity providers, and then they try to move the peg in such a way that you don't incur loss. So that's the basic idea behind that. No, you would still have impermanent loss, I think. So with V1, you would have less impermanent loss because in V1 you are just around the stable peg always. So you will like so in V1, because you just have stable assets, you will have definitely less impermanent loss than what you would have in V2, because here your prices are not stable anymore, right? So you still move. At Paraswap, yes, we do support multiple chains. We have Polygon support as well as BSC, and yeah, I'm looking forward to have swaps cross chain, but we don't have any roadmap for that yet. No, we don't have that yet, but I think it's possible to build that using something like Polygon Bridge, at least one side. Um, but yeah, there is. I mean, we are looking into that, but there isn't any specific plans yet. We are definitely looking into that. Does that answer your question? Yeah. Thank you.